Hey everyone, and I just want to go over today bond valuation. This is something you'll see in a lot of different places. It's really straightforward, and actually our present value formula in Excel is of great help with this. And I'm just going to go ahead and highlight this so you can see what is working behind this box. I'm going to go through two quick examples, one with annual compounding and one with semi-annual compounding, so you can see what that looks like. And that can be taken all the way out to quarterly, weekly, daily compounding. But just to give you a second to see what we're working with, we're using the present value formula in Excel. And this present value happens to have future value, which is going to be our par value of the bond, and then also a annuity payment, which is going to be a payment. You see this formula written out in many different ways in different books, but let's just walk through a quick example. So we have here a bond that has 5 years until it's mature. It's $1,000 par value and a coupon rate of 8.5%. A yield to maturity, so you have a cost of similar debt, what investors are requiring of similar debt in today's rates. So that's that yield to maturity. And then, we're going to try to figure out what's the market price here. What are we looking at? Well, here's two different ways to do this, given the different compounding frequencies. So let's walk through it quickly. We'll work through the variables that I always like to list for any future value, present value problem, regardless if it's just something that's, some cash flow analysis, or is it looking at a bond price, whatever that might be. Always take everything and line it up in these terms: future value, present value, payment, number of period, not necessarily the number of years, but the number of periods, compounding periods, and then the interest rate divided by how many times it compounds per year. So in this case, with an annual compounding period, we know that at some point we're going to receive our face value of the bond, that $1,000. Because this is an annually compounding bond and it has an 8.5% coupon rate, we don't actually use the 8.5% anywhere in the formula, but what we do is we use the coupon rate to figure out the annuity payment. Let me say it again: use the coupon rate to figure out the annuity payment and then set it aside, because what we're really focusing on is what's the price of this bond based on the more current, more reflective yield to maturity. So we use the 8.5% coupon rate to figure out our annual payment, or our payment per period of $85, 8.5% times 1,000. Now here's where we use the yield to maturity of 11%, because we want to use that yield to maturity essentially as our discount rate to show us what can we pay for this bond if we use this, or if we purchase it in today's environment. So with that, we will go ahead and use the full 11%. And we have 5 payments left because it's once a year, 5 years to go. So what this would tell us is that if we needed to earn the 11% yield to maturity for a bond that's going to pay us 5 payments on an annual basis of $85, and then at the end of that 5th year we receive our $1,000 principal, we could pay no more than $907.60. Another way to say it very quickly is, if we were to, the market value, the market price for this bond in this environment, given the cash flows and the current yield to maturity on similar debt, is $907.60. Just to clarify, it is a negative amount in this box because the way Excel looks at this, basically it's saying that we could have a cash outflow today of no more than $907.60. So because it sees that as a cash outflow and it sees our payments and future value as a cash inflow, it registers that as a negative number. Obviously, this bond doesn't have a negative present value. I hope this was helpful. I'm going to post another short video as to how to approach this same bond with semi-annual payments. Thanks.